The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome guys, I'm DrAvitech. In this video, we're going to be solving this very problem. It says find the Fourier series of the function defined by that. So the first thing we want to do is to find the first coefficient, which is the zeroth coefficient. So let's get started with a naught is equal 1 over pi integral from negative pi to pi of f of x dx. So that's the first what we have. That's the first coefficient that we're going to look for. Now, this function is neither even nor odd, so don't just get started with. So you have to find every single thing. So this will become 1 over pi. Now, this interval, if you notice, from minus pi to pi, but instead, we have minus pi to 0 and then 0 to pi. So we're going to break it down. We're going to say this is the integral from minus pi to 0 of f of x dx plus the integral from 0 to pi of f of x dx. All right, so this is 1 over pi. Then we're going to have the integral from minus pi to 0. Now, f of x, from minus pi to 0, f of x is 1. So this is 1 dx. And then from 0 to pi, f of x is 0. Okay, so this is what we have. And the thing is, so that in subsequent examples, if the function is 0, I don't think I have to integrate that. So I'll just get 0. So there's no need for me to integrate that. So in subsequent examples, I won't be doing that. Now remember to hit the subscribe button. Let's proceed. So this is 1 over pi. Then we have just this. So if you integrate 1, you basically get x. When you integrate a constant, you just get x. And that's from minus pi to 0. Now this is 1 over pi. Open up a bracket. Now anywhere you see x, you're going to put 0. So this is x, you're going to put 0. So this is the upper limit minus. The lower limit, you're going to put x as minus pi. So this will become 1 over pi. Then we have 0 minus minus to give us plus. So this is 1 over pi. 0 plus pi is pi. So you say times pi. Now pi will cancel out pi, so this will give you 1. So that's what you just get. So that's just 1. So that's for the zeroth coefficient a naught. Now let's find a sub n. So a sub n is 1 over pi integral from minus pi to pi of f of x cos nx dx. So that's the one for a sub n. So this will be 1 over pi integral from, now let's split it. The same way we've done this, let's split this. So we're going to say minus pi to 0. Minus pi to 0. But the thing is, the function, when it's from minus pi to 0, is 1. So this will just be 1 cos nx dx. Remember to hit the subscribe button and like this video. And the thing is, 1 times anything is that same thing. So this will just be 1 over pi integral from minus pi to pi of cos nx dx. Now if you notice, I didn't put this 0 guy because it will still cancel out. So no need for me to put the other guy. No need. So this will become, oh, this is supposed to be 0. So this is 1 over pi. Now, if you integrate cos, you're going to have sine. So this is sine nx. Then you're going to divide by the derivative of nx. So when you differentiate nx, you will get n. And then this is from minus pi to 0. All right. Now the n is a constant, so I can basically bring out that constant. So let me bring out this n. So this is 1 over n pi. And then anywhere you see x, you put 0. So this will be sine n times 0 is still 0. So this is the upper limit minus, for the lower limit, we're going to get sine n times minus n will give us minus n pi. So let me do something like this. Minus n pi. Okay. Now the thing is, sine 0 is 0. Sine of n pi or minus n pi is still 0. So everything here will just give me 0. I don't think I should be stressing myself with that. Every single thing there will give me 0. So that one is gone. Next to be b sub n. Next thing for us to find is b sub n. So b sub n is 1 over pi, integral from minus pi to pi of f of x sine nx dx. So this will be 1 over pi, integral from minus pi to 0 of sine nx dx. Now, you know that the function from minus pi to 0 is 1. So 1 times sine nx, instead of writing this one just now, 1 times sine nx will still give us sine nx. So that was what I just did. So it's easy, it's clear. Now the next is to say this is 1 over pi. Then if you integrate sine, you will get minus cos. So this is minus cos nx divided by, this is nx. So when you differentiate nx with respect to x, you will get n. So you have to divide by that very n. And this is from minus pi to 0. Okay, now this minus is a constant. So bring out the minus. The minus is a constant, so you bring it out. The n is also a constant, so you bring out the n. So this will be minus 1 over n pi. Then we're going to have cos n times 0 when you put in your limits. Because anyway you see x, you're going to put limits. You're going to put your limits. So this is x. So n times 0, when it's 0, will give us 0. Minus, oh, that's cos. Minus cos. Now, n times minus pi will give us minus n pi. Okay. Now, this will be minus 1 over n pi. And then, cosine of 0 is 1. It's a special value. Cosine of 0 is 1, so that's a special value. And then this will be minus cos of minus n pi is the same as cos of n pi. So cos, let me write it here. So cos of n pi is having the same value as cos of minus n pi. This is because cosine is an even function. So a negative input is the same as a positive input of the same value. Okay, so cosine of minus n pi, everything here is equal to minus 1 to the power of n. That's the special value for that. So this is minus 1 to the power of n. All right. Now, this would be, this bracket you see here behaves in a very funny way. The bracket you see here behaves in a very funny way. So let's see the behavior of this bracket when it's an even number and when it's an odd number. You are concerned with just the bracket, just the bracket. So we're going to say that, well, when n is odd, so our bracket is 1 minus 1 to the power of n. So let's pick an odd number. So this is 1 minus 1 to the power of this n here. Let's say is 1 because 1 is odd. So this is 1 minus 1 to the power of 1. Anything to the power of 1 is that same thing. So this is minus 1. So this is 1 minus is plus. And then the answer for that will be 2. So as you can see, when n is odd, this bracket will always be 2, no matter the odd number you pick. No matter the odd number you pick. So this tells me that my b sub n will become minus 1 over n pi times this bracket you see here. This bracket you see here is 2 because we're dealing with when it's odd. So this is b sub n equal minus 1 times 2 is minus 2 over n pi. So this is what we have when n is odd. So this is when n is odd. Now let's see when n is even. So when n is even, so this is 1 minus 1 to the power of n. So this is 1 minus 1 to the power of n, let's say 2. Because it doesn't matter the value of n you choose, provided it's an even value, your answer is still the same. So this is 1 minus. When you square a number, you're going to get a positive answer. So this will be plus 1. So this is 1. Minus plus is minus. 1 minus 1 is 0. Now if this is 0, this means that my b sub n, which is minus 1 over n pi, times the bracket, this bracket, is 0. So this will just be 0. So I'm not going to be using this. All right. Will this space be enough? Well, let's give it a try. So f of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sine nx. All right. Now we know that this value is 0, so this one is gone. Yeah, that one is gone because we know it's 0. So this will be f of x equal to a naught over 2 plus the sum from n equal to 1 to infinity of b sub n sine nx. Now what is the value of a naught? Value of a naught is 1. Value of a naught is 1. So this will be 1 over 2 plus the sum from n equal to 1 to infinity. B sub n is minus 2 over n pi. So we have minus 2 over n pi. Then sine nx. But the thing is, this value is only when n is odd. So you must always remember when you are doing this. So it's either you put it somewhere that n is odd, that you can put n equal to 1 comma n is odd, or better still, you can put in an odd representative. I will do that at the end of this. So I'll do that at the end. So let us expand this. Let's see how we can simplify this. So this is 1 over 2. The minus 2 is a constant. The over pi is a constant. So I can bring it out to become minus 2 over pi. Then the sum from n equal to 1 to infinity. What will be left if this minus 2 goes? We're going to have 1 over n sine nx. That's what we're going to get. So this will become f of x equal 1 over 2 minus 2 over pi. Now let us write out some harmonics here. Let's write out some harmonics. But remember that n must be odd. N must be odd. So this will become, when n is 1, 1 over 1 is 1, sine 1x is still 1. Because anywhere you see n, you'll be putting 1. Anywhere you see n, you'll be putting 1. So this will just be sine x. And the next value is 2. But 2 is even. And whenever it's even, you must get 0. So we're not going to put 2. Let's put 3. So this will be 1 over 3 sine 3x. The next odd number is 5. So this is 1 over 5 sine 5x. And just like that. Just like that. So this will be the answer. So you're going to put plus, the dot means it continues. It continues just like that. So this will be the answer to your question. But I said something. I said, what if you want to write this in another way? The other way to write this, especially if they say leave your answer in terms of n. So f of x is equal half. Then we have this. Let me use this expression. Minus 2 over pi. The sum from n equal to 1 to infinity of 1 over n sine nx. Where we always have to be remembering that n is odd. You might forget. You might forget that n is odd. So what do I do? What I will do is very simple. To make sure that the values I get would always be odd, all I have to do is anywhere I see n, I'll put 2n minus 1. Anywhere I see n, I'll basically put 2n minus 1. Because 2n minus 1 is always odd. So when I do this, this would then mean that my answer is in terms of what? Is in terms of n. And this will be the answer to the equation. So I will see you in the next video. Bye.